Welcome to the Explainer. So, if you've been working with large language models at all lately, you already know they are absolutely incredibly powerful. But they have a pretty fundamental limitation. You see, they rely entirely on what they memorize during their initial training. But what if, instead of relying on this static closed-book memory, we could actually give our AI an open-book test? Well, today, we are demystifying the exact system architecture that solves AI's biggest flaws by simply allowing it to look up the answers. It's called RAG.
To really get this, let's look at how standard AI operates. It basically works with a closed-book memory. When you ask it a question, it searches its internal pre-trained weights to essentially guess the most likely answer. The problem with that? That data might be completely outdated, or worse, the model might just hallucinate and make something up entirely. RAG, on the other hand, completely changes the game. It dynamically looks up fresh, reliable information from real data before it even attempts to formulate an answer.
Okay, let's break down that acronym real quick. RAG stands for Retrieval Augmented Generation. It's a very specific system design pattern with two main parts. Retrieval is the act of fetching relevant facts from external data sources. Think your internal company PDFs or your private databases. Then, generation takes over. That's where we use a large language model to actually read that retrieved information and output a clear, natural language answer. Put simply, you retrieve the facts and then you generate the response.
Here's our quick roadmap for today. We'll start by meeting RAG, then look at the key components, walk through the actual RAG workflow, discuss why RAG matters so much, and finally, look at some common use cases.
All right, part one. Let's meet RAG and look at the big picture.
If we map out the entire journey, it's like a blueprint. You start with your raw data all the way on the left, stuff like PDFs, websites, databases, you name it. When a user asks a question, the system doesn't immediately take a guess. Instead, it searches your process data, retrieves the absolutely most relevant chunks of information, builds a specialized context prompt, and only then does it ask the LLM to generate an answer. This structural flow literally guarantees that the final answer is grounded in actual data, rather than just AI guesswork. Moving right along to Section 2, the key components. Think of these as our factory parts.
Every RAG system has to begin with raw materials. Your input knowledge can be structured, like databases and tables, or unstructured, like your everyday PDFs, Word docs, and HTML pages. But to make this data instantly searchable by an AI, it ultimately gets housed in specialized databases known as vector stores. We're talking about incredibly fast technologies here, like FACE, Pinecone, Weaviate, or Milvus. These definitely aren't your standard databases. They are explicitly designed for lightning-fast similarity searches. But listen, you can't just shove a massive 500-page PDF into one of these vector stores. It just doesn't work. You need document processing. First, we clean the data, getting rid of all the noise like headers, footers, and boilerplate text. Then comes the absolutely crucial step, chunking. We split the documents into smaller, bite-sized pieces, usually right around 200 to 1,000 tokens. Think of it like cutting up a giant textbook into a stack of bite-sized flashcards. Why do we do this? Well, because retrieval works infinitely better on smaller, specific semantic units rather than massive, overwhelming walls of text. Finally, we normalize everything just to ensure the formatting is totally consistent.
Now here is where the real magic happens. Once we have those specific chunks, we turn them into embeddings. An embedding simply converts a chunk of text into a highly complex sequence of numbers. It uses a specialized embedding model to capture the true semantic meaning of the text, not just doing a basic keyword match. The golden rule you need to remember here is that text chunks with similar meanings will have vectors that are mathematically close together in space.
So what's the point of all that math? Well, a query time. The retriever takes the user's question, turns that into a vector too, and uses mathematical methods like cosine similarity or dot product to find the top matching chunks, usually pulling the top 3 to 10 best matches. It grabs those highly relevant chunks and passes them right over to the generator, which is our LLM. The LLM then uses that exact, highly specific context to draft the final natural language answer.
Which brings us to Section 3, the RAG workflow. Let's walk the assembly line.
The whole process happens in two distinct phases. Phase A is offline indexing. This is your pre-processing phase, and you just do this once, or whenever your data changes. Step 1, you collect and ingest documents from all your sources. Step 2, you process those documents by cleaning them and splitting them into those semantic chunks we just talked about. Step 3, you use an embedding model to translate each chunk into a vector. And Step 4, you save those vectors, the chunk text, and really important metadata, like source URLs or page numbers, straight into your vector store. Boom! At the end of Phase A, your system is fully search-ready. Then we shift into phase B, the online answering phase. This is the stuff that happens live, at runtime, every single time a user asks a question. First, the user's question is instantly converted into a vector using the exact same embedding model from before. Next, the system searches the vector store to retrieve the highest scoring, most relevant chunks. Step 3 is critical. It builds a context prompt, basically mashing up the user's question with those retrieved chunks. Finally, the LLM reads that tightly focused context and generates a thoroughly grounded answer. And the best part? It can even throw in optional citations to prove its work, just like a really good math student.
Okay, let's strip away all the technical jargon for a second. Here is the radically simplified flow. 1. You ask a question. 2. The system retrieves the relevant data. 3. The LLM uses that specific data. 4. You get a context-aware answer. It is quite literally an open book test for the AI. You are forcing the machine to open the textbook, find the highlighted paragraph, and read it back to you in its own conversational words.
All right, Section 4, why RAG matters and its real-world impact.
There are 5 absolutely massive benefits to doing things this way. First off, it's vastly more accurate because it's using real data, not just relying on a vague model memory. Second, it's always up to date. Need to add info? Just drop a new PDF into the vector store. No crazy expensive model retraining required. Third, and this is huge, it drastically reduces AI hallucinations. No more AI confidently making up fake legal precedents, because the answers are strictly grounded in the retrieved context. Fourth, it's fully transparent. RAG can actually show you the source citations and page numbers. And finally, fifth, it seamlessly integrates your custom, private, domain-specific knowledge that the AI was never originally trained on.
Which perfectly leads us into Section 5, common RAG use cases. Let's look at where this is being used today. Make no mistake, RAG is completely transforming how we interact with information. We are seeing it power incredibly smart Q&A bots over dense technical manuals and giant company policies. It's totally revolutionizing enterprise search, finally allowing employees to instantly query internal company data and actually get an answer. It's drastically improving customer support bots and being used for massive research and summarization tasks. And honestly, it's becoming highly critical in specialized, high-stakes sectors like legal, healthcare, finance, and education. In those fields, you absolutely cannot afford a hallucinated answer, and every single claim must be backed by a custom, domain-specific citation. At the end of the day, RAG shifts AI from being a creative guesser into a precise, verifiable researcher. It unlocks the true hidden potential of your organization's unstructured data. So I'll leave you with this to think about. As you look at your own workflows, your own databases, and your own internal documents, what custom private knowledge will you empower your AI open book test with? Thanks so much for joining me on this explainer, and keep exploring.